Today, we mostly treat these signals as embarrassing accidents. You blush, and you apologize for it. You yawn in a meeting, and you cover your mouth like you've committed a small crime. We've built an entire culture around suppressing involuntary body language, treating it as noise to be managed rather than information to be read. But that assumption is recent, and it's wrong. For most of human history, and for millions of years of primate evolution before that, these signals weren't malfunctions. They were the primary communication system. Language is maybe 100,000 years old. Blushing, crying, and goosebumps are millions. We're going to start tearing that baseline apart piece by piece, starting with the reddest one. Take blushing. Charles Darwin devoted an entire chapter of his 1872 book, The Expression of the Emotions in Man and Animals, to it, calling it the most peculiar and most human of all expressions. He sent questionnaires to missionaries and colonial officers across dozens of cultures from Malaysia to New Zealand to South Africa, asking one specific question: do the people you observe blush? The answer, again and again, was yes, universally, even in populations with skin tones dark enough that Darwin himself doubted the flush would be visible. Mechanically, blushing happens when your sympathetic nervous system triggers beta-adrenergic receptors in the blood vessels of your face, dilating them almost instantly faster than nearly any other vascular reflex in your body. Here's the thing: your face has a denser network of these blood vessels than almost anywhere else on your skin, which means evolution didn't accidentally make your face flush-prone. Biologist Ray Crozier at Cardiff University has spent decades studying this and argues blushing evolved specifically as an appeasement signal, a way of saying, "I know I broke a social rule, please don't punish me for it," without saying a word. It's involuntary precisely because a voluntary apology can be faked. Now compare that to something that feels completely unrelated: yawning. The average yawn lasts about 6 seconds and involves nearly every muscle group in your face along with a jaw stretch that briefly increases blood flow to your brain. But the part that should actually unsettle you is contagious yawning. Around 60 to 70% of people will yawn within a few minutes of watching someone else do it, and researcher Stephen Plotek at Drexel University found something specific in the early 2000s. People who scored lower on empathy tests were significantly less likely to catch a yawn from someone else. Chimpanzees catch yawns from humans. Dogs catch yawns from their owners. And a 2008 study out of the University of London found dogs were more likely to catch a yawn from a familiar person than a stranger. Here's where it gets interesting: if contagious yawning were purely about tiredness, none of this social patterning would make sense. Instead, it looks like a synchronization signal, something that evolved in social animals to align group states, the same way a yawn ripples through a room and, weirdly, tells you something real about how emotionally connected you are to the people in it. Then, there's goosebumps, which might be the clearest fossil of all. The technical term is piloerection, caused by tiny muscles called erector pili contracting at the base of each hair follicle. In a species covered in thick fur, this does two jobs. It traps a layer of warm air against the skin in the cold, and it makes the animal look physically larger when threatened. You've seen this exact mechanism in a startled cat, whose fur puffs out along its spine and tail in under a second. Humans have roughly 5 million hair follicles, nearly the same density as a chimpanzee, but our hair is mostly too fine and too short for either function to actually work anymore. And yet the reflex never got deleted. You still get goosebumps at a symphony's climax, during the final scene of a film, or when a song hits a note you weren't expecting. Neuroscientist Robert Zator at McGill University has run brain scans showing that skin orgasms, as some researchers informally call them, activate the same dopamine reward circuitry as food, sex, and drugs. Here's the thing: you're getting a threat response from Beethoven. The hardware built for a predator on the savannah is now firing off during a key change, because the emotional intensity registers the same way to a nervous system that never got the memo that concert halls aren't lion territory. Because this is exactly the same pattern as blushing and yawning, an ancient survival mechanism, repurposed by evolution or by circumstance, still running in a modern context it was never built for. Let's go somewhere almost nobody thinks to look: the whites of your eyes. In 2001, researchers Hiromi Kobayashi and Shiro Koshima published a comparative study across 88 primate species and found something remarkable. Humans are essentially the only primates with a visible white sclera. Chimpanzees, gorillas, and orangutans have dark, pigmented sclera that blend with the iris, making it very hard to tell where they're looking. Human eyes do the opposite. They're practically designed as a directional signal. This is called the cooperative eye hypothesis, and the logic is unsettling once you sit with it. In a species that survived by group hunting, shared childcare, and coordinated defense, being able to instantly see where someone else is looking without them saying a word was a massive advantage. But here's what nobody tells you. That same trait that helped us cooperate is also what makes deception so hard for humans specifically. You cannot hide your gaze the way a chimpanzee can. Evolution apparently decided the benefit of transparent group coordination outweighed the cost of not being able to lie with your eyes. Now, tears. Not the reflexive kind that flushes out an eyelash, the emotional kind, the kind that shows up when you're grieving, overwhelmed, or even overjoyed. Biochemist William Fry II ran a study out of the University of Minnesota in the 1980s comparing emotional tears to irritant tears, like the kind triggered by cutting an onion. He found emotional tears contained measurably higher concentrations of protein-based stress hormones, including ACTH-related compounds, along with manganese levels roughly 30 times higher than in blood serum. His hypothesis, still debated but never fully disproven, is that crying isn't just an emotional overflow, it's a literal excretion mechanism, purging stress-related chemicals from the body. Here's the mechanism that matters more, though. Humans are the only species definitively known to produce emotional tears as a visible, social signal. A crying face is almost impossible to fake convincingly, and blurred vision from tears makes you temporarily more vulnerable, which is exactly why researchers, like evolutionary psychologist Orrin Hassan, argue crying works as an honest signal of distress. You can't fully weaponize a signal that costs you your own eyesight while you're sending it. Then there's hiccups, which sound trivial until you learn where scientists think they came from. A hiccup is an involuntary spasm of the diaphragm followed by a sudden closure of the vocal cords, producing that unmistakable hic sound. Fetuses hiccup in the womb starting as early as 9 weeks, long before there's any air in their lungs to hiccup on. In 2003, physiologist Daniel House proposed a theory that since gained real traction, hiccups may be an evolutionary leftover from our amphibian and fish ancestors, a motor pattern related to how tadpoles and lungfish push water across their gills while simultaneously keeping it out of developing lungs. Here's the thing. The same brainstem circuitry involved in hiccups overlaps almost exactly with the circuitry amphibians use for gill ventilation. Last one, and it's the one you'll notice within the next 60 seconds, blinking. You blink somewhere between 15 and 20 times per minute, which adds up to roughly 10,000 times a day, far more often than your eyes actually need for lubrication, which researchers estimate would require only 3 to 4 blinks per minute. So what's happening in that extra blinking? A 2013 study out of Osaka University led by Tamami Nakano used fMRI scans and found that spontaneous blinks cluster at natural pause points in speech and attention, the ends of sentences, breaks in a conversation, moments where a listener briefly disengages from processing information. Blink rate also visibly changes with cognitive load and even deception. It tends to drop sharply during intense focus and spike right afterward. Poker players, interrogators, and body language researchers have known this instinctively for decades. Here's where it circles back to everything else in this film. Your blink rate, like your blush, like your goosebumps, is a live readout of what's happening inside your nervous system, whether you intend to broadcast it or not. So look at everything you've got. You've got blushing, an involuntary apology written in blood vessels. You've got contagious yawning, a synchronization signal that tracks empathy in real time. You've got goosebumps, a threat response hijacked by music and awe. You've got visible sclera, a cooperation tool that makes you constitutionally bad at hiding where your attention goes. You've got emotional tears, a costly and literally vision-impairing honesty signal. You've got hiccups, quite possibly a 400-million-year-old gill reflex still firing in a body with lungs. And you've got blinking, a constant low-level readout of your cognitive and emotional state playing out roughly 10,000 times a day. Here's the single thread running underneath all of it. None of these signals exist because your body malfunctions. They exist because, for the overwhelming majority of the time humans have existed, survival depended less on what you said and more on what you couldn't help revealing. Trust had to be built on something harder to fake than words, because words are cheap and always have been. A blush, a tear, a dilated pupil, a synchronized yawn, these are the receipts. They're expensive to produce and hard to counterfeit, and that's exactly what made them valuable in a species that lived and died by its ability to cooperate with near strangers. Language gave us the ability to lie efficiently. These older systems are the reason we still, on some level, know when something doesn't add up.